Okay guys, so we're going to go ahead and continue the last video on 5.4 logarithmic functions. So we were taking the derivatives of logs in the last video. Now we're going to go ahead and just continue the second page of the worksheet. So here I have the log of something being divided by something else, and then all of this is cubed. Now I could just take the derivative. I could follow the rule and say y prime is 1 over all of this mess to the third, and then times the derivative of all of that mess, and that would just be messy, right? So no, I'm not going to do that. That will take almost a whole video length. So here's what we're going to do. We're going to use the properties of logarithmic functions. So let's do this. I got a power property. Bring it to the front. 3 ln e to the 3x minus 1 all over 3x squared. Now using the quotient property, if I have a quotient, I can write it as a difference. 3 bracket ln of the top minus 1 minus ln of 3x squared, which is the bottom, and that's it. Distributing the 3 will give me 3 ln e to the 3x minus 1 minus ln. Well, check this out right here. I'm distributing the 3. I'm going to distribute it here, so I'm going to go ahead and put 3 here already. Okay, but look at this. Now I have a 2 to go in the front of that, so it's going to be 3 times 2, which is really just 6 ln of 3x. Now there's no special property here, because notice that I have a e to the 3x, which I could take my 3x to the front, but now I have a different argument. Now it's being subtracted by 1, and you can't do anything else with this part. So we're going to leave that like that. Now I can take my derivative. So all this was not even the derivative. Now I can take my derivative of this function right here, and let's begin. 3, the derivative of ln something is 1 over that something times the derivative of whatever that something was, so it's going to be 3 e to the 3x minus 6, which is now the second part. It's going to be the derivative of ln 3x is 1 over 3x times the derivative of 3x, which is 3. And we see that we have really messy stuff. So it's going to be 3 times 3, 9 e to the 3x all over e to the 3x minus 1 minus 6. Well, it's actually minus, well, it is minus 6 because I can knock off the 3's. So minus 6 over x. And I refuse to do anything else to continue this part here, so I'm going to leave it like that. So I'm done. Okay, so now we have y equals the square root of x squared minus 1 over the cosine x squared, cosine squared of x all to the third. Yay, isn't this so much fun? Using the power rule, 3 ln the square root of x squared minus 1 over cosine squared x. Using the quotient rule now, it's going to be 3 ln of x squared minus 1 minus ln of cosine squared x. 2 is also a power. Well, actually, since we're talking about powers, the square root of x is a power to the half, which could also be brought down to the front. So I'm going to have 1/2 ln x squared minus 1, nothing else I can do from there. Let me move this more over here. Minus 2 ln cosine x. Now that's a lot more easier to compute rather than computing the derivative of a chain rule, of a quotient rule, of all this mess. So that's not easy. Let's rewrite this one more time so that I can have everything together. Okay, now I can take the derivative of this, starting with 3/2 ln x squared minus 1, which is 1 over x squared minus 1 times 2x, the chain rule, minus 2 1 over cosine x times negative sine x, the chain rule of cosine. Let's clean this up a little bit. So it's going to be 2's cancel, 3x over x squared minus 1 minus, well, a double minus will give me a positive 2 sine x over cosine x, and I can rewrite that one more time. Not plus, minus, plus 2 tangent x. And that's pretty much all as far as I will go. Here is my derivative. Now let's be realistic. I'm going to be honest with you guys. You're probably not going to have a problem like this on your AP exam. If anything on the AP exam, it'll be maybe something like, I don't know. I don't have a good example here, but it's not going to require you more than like 2 minutes of work. Okay, so if you're pretty quick, anything that's beyond 2 minutes like this problem is more than likely not going to be on the AP exam. So let's go ahead and talk about this last problem here. Okay, so in this problem, we actually can't do it right now because it requires what's called implicit differentiation, which is going to be on your next topic in your next set of notes. So I'm going to go ahead and put a star next to this so that for anybody that wants to try it using this video, do that as an exercise after you have learned implicit. And if you can turn it into me in class without any aid, I'll give you some extra credit. So that's pretty much it for these sets of videos. This is the last part of the derivatives of exponentials and logarithmic functions.